In this lesson, we talked about solving expressions that are usually in the form something equals something else. And we talked about solving exponential expressions like these when we can't create common bases. We solved a process, or we did a process to solve those. And then we also talked about questions like these where we have some singular thing equals some other thing, and then in that case we create like bases. So wherever possible, we're going to use the more efficient method, create like bases. If not, you use the second process. Now, sometimes I get a question like this where I have multiple terms in here. I could try to take the log of both sides here, but the problem is that even if I were to try and maybe bring this over to the other side, so maybe I have something like this equals negative 3 to the x. The issue here is that even if I log both sides, it's the log of this whole thing, and I actually can't bring that exponent down, can I? Because it's inside a logarithm. So that becomes a problem for us. I can't take the log of both sides here. I can't get these in a format because I have more than 2 terms here. I can't really get this in a format where I can use log. So in these types of questions, we call these types of questions hidden quadratic questions. We're at lesson 4. We're going to do example 5, and then we'll go back to example 4. So the way that we can recognize these types of questions are, you will notice a couple things. You're going to notice that you have 3 terms. Okay? They might be all on one side, like this one. They might be some on one side, some on the other side. And you will also notice either one of 2 things for these types of questions. You will notice a common base with exponents of either 2x and x, or you will notice something like in example 4 where you have still a common base, so this one is 2 and 2, but instead of exponents of 2x and x, you have exponents of negative x and positive x. Okay? So the easier version of this question is example 5, so I want to start with that one. And this is already sort of set up in a nice format for us. We have common bases of 3, exponents of 2x and x, and we have a constant value. And they're sort of arranged in descending order. So I have 3 to the 2x, 3 to the x, and then the constant arranged here. So what we're going to start with here is we're going to start with a let statement because this is going to help us see this question in a bit of a different format. So I'm going to start with let the common base that I see here, I'm going to let 3 to the x equal some variable. Doesn't really matter. Usually we use k. And let statements sometimes can help us in questions like these because they give us a way to sort of simplify this question so it looks familiar, or they make it a little bit less complex for us to solve. So I'm going to sub in, wherever I see a 3 to the x, I'm going to sub in k. And this part right here, the 3 to the 2x, would be maybe more helpful if we write this as 3 to the x squared. And that's equal to this because if I have 3 to the x squared, I multiply x in 2. So I'm just writing this in a bit of a different way so that we can see when we sub in k here, we actually get k squared plus k minus 12 equals 0. And do we all recognize this? This is a familiar type of equation, right? This is a quadratic equation. How do I solve quadratic equations? What are the options? Athena? Okay, so the first thing that we would always check is, can I factor? What if I can't factor a quadratic? What do I have to do to find the solutions to the quadratic? Lexi? Quadratic formula. Okay, so I would just always say, let's try to factor first, because that would be probably quicker and easier. So are there any 2 things? This is also an easy trinomial, so that's nice. Are there any 2 things that multiply to the c value, negative 12, and add to the b value, positive 1? 4 and negative 3 fits. And I would just plug them right into the brackets, right? No need to do factoring by grouping or anything like that. Right into the brackets. So what are my k's equal to here? So in other words, what are the solutions? Jessica?
Or like -4 and 3.
Okay, so k equals -4 and k equals +3. These aren't the solutions, right? Because I want to solve for x. So when you create a let statement, you always need to have that let statement come back into play, and you need to solve using your let statement. So I'm going to sub each of these k values back into the let statement here, and we'll solve separately for x in each one. So I'm going to have a case number 1 where k equals 3, and I will solve a case number 2 where k equals -4. So this equation might have multiple answers. It's possible that I could have an equation that doesn't just have one x value that's an answer. It could have multiples. So let's sub this back into our let statement. Our let statement said 3 to the x was equal to k. So I'm going to sub that in for both cases. 3 to the x equals 3, and we need to solve for where 3 to the x equals 4. Okay, and maybe just you can write yourself a note. Sub back in to let statement. And that was 3 to the x equals k. Okay, so this one's pretty easy to solve, right? 3 to what exponent equals 3? 1. So x must be 1 in this one. This one's a little bit tougher. Caleb, can you just shut the back door there for us? This one's a little bit tougher, right? Because I don't really know 3 to what exponent equals -4. So this is the point where we can use log to help us. So I will log both sides. Or if you want, second method, like what we practiced in our quiz, switch it into logarithmic form. And then you can use power rule, bring down the x, and divide out log 3. Okay, so what happens when we calculate here? Error. Why do we get an error? Carol? Can't take the log of a negative. We also can't take the log of 0. So remember, this is back in our first lesson, we talked about the domain and range of logarithmic functions. And logarithmic functions are only defined for values that are greater than 0, because they kind of look like this, right? And there's an asymptote on 0. So I can't have x's, or I can't plug in values into the logarithm that are negative, and I can't plug in 0 into a logarithm. Otherwise, I will get an error in my calculator. And this basically means we would call this something like an extraneous root. And that means that that particular k value that we found is actually not going to result in a solution for this. Okay? So no solution for where k equals -4. Okay, so this is actually not going to produce an x value that works for us. So this is the only answer. It would just be x equals 1. How can I check my answer? Lexi? Put it back in the original equation. Make sure you get that the left side here is equal to 0 when you sub it back in for the x's. Okay, so again, for all of these, you sub back in to check. Can I answer any questions on this one? Okay, let's flip back to example 4. This one is the slightly more challenging version of what we just did. Okay, so again, I can't really solve this by taking the log of both sides because I have two terms that are being added. Even if I were to take the log of both sides, it's not going to help me get the x out of the exponent. Because if I took the log of this, I'd have the log of this whole thing. I can't bring down any exponents when I have additions and stuff like that happening. So log of both sides is not going to help us. What you will notice here, though, is that we have 3 terms, 1, 2, 3, and I have 2 common bases, 2 and 2, 2 exponents with x's. That's how I know I'm going to use this process that we're going to use here. Okay? This one is the other version where we have exponents of 2 to the x and x. You can also have 2 common bases with exponents of negative x and positive x. If you have a case like this where you have exponents of negative x and positive x, I can actually rewrite this using the negative exponent rule. What's the negative exponent rule? What does it tell me I can do to make this exponent positive? Athena?
You can write it as 1 over 2 to the x. So you can multiply the denominator.
Okay, so I can write this as 1 over 2 to the x. So we move that down into the denominator and just make that exponent positive. Okay? Just applying negative exponent rule here. So it's going to be tough for me to solve for x if I have a 2 to the x. Not only the x is in the exponent, but it's also one of them is in the denominator. That's going to make my life pretty challenging here. So we're going to do something similar to some of those m and n questions that we were working with last unit. We had a couple that we were dealing with some fractions, and we can get rid of the fraction by just multiplying by a denominator that we see, right? So this is the denominator here. If I want to get rid of that, or if I want to eliminate having a denominator here that has 2 to the x in it, I'm going to come through and I'm going to multiply every term by 2 to the x. And the nice thing about this is that now these will cancel, and I don't have a 2 to the x in a denominator anymore, which is the goal. I don't really want to have that. So I'm going to have 14 plus 2 to the x times 2 to the x equals 8 times 2 to the x. We're going to simplify a little bit here. So what do I do with the exponents if I'm multiplying 2 like bases? How do I simplify something like that? Billy? I add the exponents. So the rule is keep the base and add the exponents.
Why don't you multiply the 14 by 2?
This is one whole term right here.
Oh,
Terms are just separated by pluses or minuses or on the other side of an equal sign. Okay, can I write this as 16 to the x? No, I cannot, right? Why not? Really?
Because the 2 is attached to each other.
Yes. Looking for a little bit more here. Lucas?
Well, you follow bedmass, you have to start with exponents first, and then multiplication.
Yes.
That was the other.
So you are violating bedmass rules, right? If you do 8 times 2 and write that as 16 to the x. Because bedmass says, brackets, exponents first, then you can do divisions and multiplications. So if I do the multiplication first, I'm violating the exponent part of that for bedmass. Carol? You could do that. We're not going to do that because it will lead us down the wrong path. But yes, you actually could. But if this were 7, we couldn't do something like that, right? So I'm going to leave this as is, and then I'm going to express this as this will become x plus x is 2x. And I'm also going to move this term to the opposite side. So get all terms on one side. Okay, so we have multiplied every term by 2 to the x. We have simplified, or in other words, distributed that 2 to the x into every term. Now I want to just rearrange this so that we're in a similar format to what we had in this question, which is I want the base with the 2 to the x, then the base with the x, then the constant. So let's rearrange this in descending order. So 2 to the 2x will be first, minus 8 to the 2x, plus 14 equals 0. Okay, so this is now rearranged. Now we're in a format like the one that we had just done. So this takes a little bit of extra work at the beginning. If you have a negative x and a positive x, you will have to come through and multiply each term by 2 to the x, or whatever the base is, right? in this case, it's 2 to the x. If it was 3 to the negative x and 3 to the x, I'd multiply every term by 3 to the x. And get it into this nice format where we have 2 to the 2x, 2 to the x, and then the constant. Now we can do what we did last time, which is we'll use a let statement. So in this case, I will let the common base, which is 2 to the x, equal our variable k. And I'm just going to plug that in. So this will be k squared minus 8k plus 14. Can I factor this? Are there any two things that multiply to 14 and add to negative 8? That would be the first thing I would always check for these. No. So factoring is not possible here. We must use quadratic formula. So just as a reminder, quadratic formula is x equals negative b plus or minus 4ac over 2a. And in this case, we'll actually use k, right? Because we have k as the variable in our question. So a is equal to 1, b is equal to negative 8, c is equal to 14. Let's plug into quadratic formula. Okay, I'm just going to simplify this. And I would like to leave this in exact form until we are able to solve back into the let statement and actually solve for the actual x value here. So these are just k values right now. So we're going to do a reminder of grade 11 stuff. We worked in grade 11 to simplify expressions like this as much as possible using radicals and perfect squares and all of that good stuff. So how do I simplify the square root of 8? What's the simplest form I can leave that in? Tina?
Is it 2 again, 3?
So I'm just saying, how do we simplify, like, so no exponents or anything like that, just how do I simplify a radical? So thinking back to grade 11 here. Lucas? So I'm not trying to create a base of 2, I'm just trying to reduce a radical. Mathashini? Yes, so we look for perfect squares inside our radical, which inside of 8, obviously we have 1 and 8. That's not going to help us simplify it any further. And then we also have 4 and 2. And 4 is a perfect square. And what I mean by perfect square is that 4 can be square rooted to give me a whole number. So I'm going to square root 4. Actually, maybe we'll go up to the next line here. I'm going to square root 4, and it's going to give me 2. So I will have plus minus 2 root 2. Okay, so remember, one of these has to be a perfect square in order to simplify the radical. So in this case, 4 gets square rooted to 2. Does anyone remember the last step of how I simplify this? Athena? Yeah, so basically I'll just common factor a 2 out from the top. I'll be left with 4 plus or minus. So if I divide this by 2, I get 4. If I divide this by 2, I'm just left with root 2. So common factor. Or in other words, we just divide everything by 2 other than underneath the root, and then these will cancel. So I have 2 options for k. I have a case 1 and a case 2. K number 1 will be 4 plus root 2. K option 2 will be 4 minus root 2. Okay, this is the hardest version of this question. If you can do this one, you can do any of them. Okay, and we're almost done. We're just going to take our k values now, and we're going to sub them back into our let statement and solve for k. Okay, so for case 1, I will set 2 to the x equal to 4 plus root 2. And for case number 2, we will set 2 to the x equal to 4 minus root 2. Okay, just plugging them back into our let statement, 2 to the x equals k. Okay, so let's solve here. I think we can just do, we'll log both sides, bring the x down. So log and log. Parachute your x down in front as a multiple, power rule, and then divide out the log of 2. Or if you want to use change of base method, that's fine too. And let's round to 3 decimal places here. See if we can enter this into our calculators. What did we get? Oscar, what did you get? 3.
2.437.
Great. Okay, this one, the process will be the same. Can we just jump here? We'll just say x will also be equal to log of 4 minus root 2 over 2. We don't need to go through that whole solving process again, right? That's silly. Okay, so just plug into your calculator one more time, but with a minus this time. Dina? 1.371. Perfect. So this one actually has 2 solutions. You can check both of your solutions again by just plugging them both right back into that original equation. So the very first one that we started with, and just make sure you get 8 equals 8 when you simplify. It might be slightly off just because we've rounded the decimals a little bit here. Okay, can I clarify anything? Lucas?
Just wondering, why can't you divide both sides by 14 additionally?
Because then I'm going to get over 14 here and over 14. And then I'll still have a 2 to the x in the denominator.
Okay.
So it just creates more fractions. So in our quiz, guys, we had a question that said 4 times 3 to the x. I don't know if there were, oh, the brackets were around 4. Doesn't really matter, but it was 4 times 3 to the x equals 67.23. So given what we just discussed about the 8 and the 2x, was I allowed to write this as 12 to the x to start? No. So I've seen this on the quiz already a couple times, so just a reminder. What would be the first step to help start this out? Oliver? Yeah, start by dividing both sides by 4. These will cancel. Then you have the base and the exponent alone on one side, and then you can go ahead and take log of both sides or use change of base or whatever. Okay? So just an important thing. I'm just noticing that a couple times on the quiz. Okay. So we are going to do, so just practicing some of the quadratic formula stuff here. I would suggest 6 and 7 from the worksheet. And then I'm going to give you the rest of class. This next lesson here, it's not actually a lesson, it's just an assignment. So this assignment, there's 13 questions. I actually had a couple students finish yesterday. They're not super long. This needs to be done by the next class. So that will be due for Monday. And you have the rest of class to work on that. So 6 and 7 from the worksheet, and then move forward to the log rules and exponential equations assignment. Please, there is no answer key on here.